Hi everyone, we're group 6, and today we'll be presenting our 5th grade science lesson, which we named Mystery Rock Detectives. Our standard focuses on observing and measuring materials to figure out what they're made of and that's what we'll be exploring through our rock investigation. In our lesson, students will step into the role of scientists, or as we like to call them, rock detectives, and they'll use clues like color, texture, hardness, and luster to solve the mystery of what their rocks are made of.
All right, rock phenomenons. For our engage aspect, it's definitely one of the most important ones. The engage phase is all about sparking curiosity, capturing the students' interest, getting them wondering. Instead of giving them information right away, we want to present them with something interesting or puzzling to have them start asking these different types of formative questions. So for our lesson, we're doing this by having students bring rocks from their own homes, their own backyards, and asking them to please respect our natural spaces like parks, national parks, and all that because we want to leave no trace behind. Um, and then once our students bring their rocks to the classroom, we will then engage them in a form of class discussion, whether that be a think, pair, share, whether that be in groups. We can do different things. And we'll be having leading questions like, what do you notice about your rock? How is it similar or different from your partner's? What do you think your rock might be made of? And that will ultimately guide us into our driving question of how we can identify materials using the properties in front of us. So how can we identify rocks like the one on this slide? By noticing like, is the rock smooth? Does it have texture? What do we see the speckles? What are those things?
Okay, so yes, that leads us right into the video we're going to use within our engage stage. Now that the students have explored each other's and gotten their juices flowing with their background knowledge, we're going to show them this video about rock formations, and that will lead us into they'll be after they're done watching, we'll ask and pause and ask questions um, about the comparisons they might see with their own rocks, and they'll be able to hear better descriptions of their rocks, maybe compared to what they were exploring and saying. This will then lead us into our next slide, which leads us into what we will be using for our explore phase. These materials would include obviously our rocks, but we'll also have a classroom rock kit for each student, or at least for each grouping. And we'll make sure they have magnifying glasses to take a look at these things. Cups of water, maybe cups of vinegar, different solutions to test out their rocks in to see how they react or how they compare. Paper towels as well, because obviously we're going to be using liquids, but also to see they can use it to dab their rocks and see, is their rock porous, or does their paper towel get really wet, or did the rock itself sop a lot up? And obviously finding out if it's a magnetic or not is a lot of fun for the kids. They also can then use their rulers, and then on top of that, we're going to have them use a form in order to write all of this down.
So now that we have our materials ready, it's time for the students to think like real scientists. So on this side, as you could see, we have two different charts, which we'll walk them through on how to record their observation using either or charts. We'll show them examples of each property so students know exactly what to look for. So we could ask them questions like, what color do you see when you hold your rock up? Does it feel smooth, rough, or powdery? We could try a quick scratch test using our fingernails to test the hardness of it. We'll model how to fill in one row together so that students know how to describe what they see. There's also an opportunity to create a space for low floor high ceilings within this lesson by allowing students to use rock identifying charts if they would like, and if they would instead prefer to challenge themselves by not using one. So here you could see our sample data. Sorry. Thank you. And it models how scientists could record or organize their evidence. And students can use this as a guide to check to see if they've described each property accurately before moving on to actually identifying their rocks.
As far as completing the lesson, something to expand upon, if we go back to our chart, that last column, we thought about removing it because we just got one of these charts from the internet, and there's a wide variety of different charts that you could use for data collection or make your own if you prefer something different as a teacher for what you want them to explore. But in this last tunnel, it said good for tunnels Y, and we thought that would be a great way to when wanting to complete the lesson to be able to elaborate. That's like a really great critical thinking question. Like, can we use these rocks to build things? Can we use these rocks to like do certain items or not? And just having those discussions would be really great to elaborate. To explain, we would have them review the identification of their rocks all together. Like, what did they get wrong? What did they get right? So, like, we could review, like, maybe us as educators, we missed something or need to clarify something. And then for the evaluate, we would do something like an exit ticket, or we could do even a final quiz at the end of the unit or whatever, to discuss their rock identification. So basically have them do that on their own, independent of charts and tools.
So these are some alternative ideas that could be used for a lesson like this. You could, if you were not using the rock idea, you could still um, explore the standard by looking at formations and exploring matters of different types using the Mentos there in the soda. But you could look at things like salt, and even though sugar is not a a rock, you could have, because they look similar, again, they're comparing and contrasting and being able to look at the different components. We can go to the next slide. So in wrapping things up, what I wanted to also come back to was our driving question of taking a look at being rock detectives and what do you notice about your rocks. Did we have that back? Yeah. How can we identify materials using observable properties? So throughout this time of all of the stages, the students are being able to identify what types of properties they are, how they were able to observe them, and then how to identify based on those components, and look for clues and be that detective. So let's see. We have any other things that we wanted to talk about in this? I think that's about it. So thank you so much for hearing us out today. Have a great day.